And finally, I'd like to talk about another case where you can multiply or divide divide both sides of, let's say, a relationship by the same number. So let me show you what I mean. So, for example, I want to make up a solution and I'm interested in magnesium ions, Mg2+. And you can get those from MgSO4, magnesium sulfate, which has a molecular weight of 120.4, or magnesium chloride, whose molecular weight is 95.2. And let's say that in my protocol it says to add 20 grams of magnesium sulfate to my solution. But I only have magnesium chloride, so how much to get the same molarity of magnesium ions? So this hinges on the relationship, the proportion between the molecular weights of these two compounds, because there's the same number of magnesium atoms in each, so we need to add the same number of moles of each to have the same molarity of magnesium, but we're stuck with a number of grams. So what I like to do is write out, so we have 20 grams of magnesium sulfate, and that is the molecular weight of 120.4, and then how many grams magnesium chloride, and that has a molecular weight of 95.2 grams. So here's the same idea. We're going to look at the proportion between the molecular weights and then go from there to the grams. So to the relationship between these, so 95.2 divided by 120.4 is equal to 0.79. So if I multiply 120.4 times 0.79, that gives me my 95.2 molecular weight of the magnesium chloride. And so with my grams here, I have to multiply by the same number. I'm multiplying by the same thing on each side, and so that gives me 15.8 grams. That's my answer. So thinking about proportions in this way in all sorts of situations can be really helpful when you're doing maths for biology.